Okay, now we're going to look at a couple systems with three unknowns. We're going to keep it pretty basic for right now. So I look at 2x plus y equals 10, 3x equals negative 12, and 3y plus z equals 20. With this, again, we want to find the equation that helps us the most, and that's an equation if it has one variable only. So the 3x equals negative 12 is the most beneficial equation because I could just divide by 3 and get x equals negative 4. Then I go back up here and I say, well, this equation has x and y, so if I know what x is, I can substitute. So I can look at 2x plus y equals 10, but I also know I know x is negative 4. So if I take 2 times negative 4, it gives me negative 8, plus y equals 10. So then I can add 8 to both sides and get y equals 18. Then from here I take the y and I look at the last equation, which is 3y plus z equals 20. And since y is 18, we put that in. 3 times 18 is 54, plus z equals 20, and then I would subtract 54 from both sides. So I'd get z equals negative 34. Then once you have x, y, and z, write it as an x, y, z ordered pair. Okay, the second one. 3x plus y equals 25, negative 4y equals 20, and 4z plus 2x equals negative 10. So again, find the one that has one variable. So negative 4y equals 20. So I divide by negative 4, and I get y equals negative 5. So then I go back up here, and I look at 3x plus y equals 25, and I can substitute negative 5 for the y. Then to solve that, I add 5 to both sides. 3x equals 30, then divide by 3, x equals 10. So now I've got x and y, so now I can go to the third equation, which is 4z plus 2x equals negative 10, and I can substitute the 10 for the x, which gives me 4z, 10 for the x, 4z plus 20 equals negative 10, subtract 20, and get 4z equals negative 30, divide by 4, z equals negative 30 over 4. Now I know that doesn't divide evenly, but if I reduce, 2 goes into both of those, so it'd be negative 15 over 2. So then I would write x, which is 10, y is negative 5, and z is negative 15 over 2.